Welcome. In this video we look at our day 2 for Unit 4. Unit 4 is linear functions and models, and in this video we will focus on the linear models. We're in section 4.2 and we'll look at the first two objectives: draw and interpret scatter plots, and then distinguish between linear and nonlinear relations. So let's draw and interpret scatter plots. Take a look at the data on the right. There are 15 Major League Baseball teams, and for each baseball team, the first column tells us the on-base percentage of the players on that team and the total runs scored. Oh, and I should say this is for the year 2017. So, for example, the Pittsburgh Pirates. During the year 2017, their players had an on-base percentage of 31.8%. That means when a player gets up to bat, then the percentage of time that they actually make it to first base safely is 31.8. Either they can get a hit, or maybe it's a walk, or they're hit by pitch, but one way or the other, they get to first base safely. And for the Pittsburgh Pirates, on average, their team got to first base safely 31.8% of the time. The Pirates, over the course of 2017, scored a total of 668 runs, and that's when the player runs from third base to crosses home plate safely, and a point is scored for the baseball team. So it kind of makes sense that if your on-base percentage is good, then the total runs scored will be pretty high. Take a look at the team under the Pittsburgh Pirates, the San Diego Padres. They had a slightly lower on-base percentage, and correspondingly their total runs scored for the season was a little bit less. So we can take all this data and we can imagine the on-base percentage as an X value and runs scored as a Y value, and we get a whole bunch of points. Then we can plot those points, and this is what we get. So let's see, the Pittsburgh Pirates, I believe 31.8 and 668, so that's the Pittsburgh Pirates right there. And the San Diego Padres at 29.9 and 604, there we go. So every dot on this graph represents some baseball team, and the x-coordinate is the on-base percentage, and the y-coordinate is the total runs scored. Now, this scatter plot, this bunch of points, is kind of linear. It sort of, more or less, kind of goes in a line, and I can make a line that goes through that cloud of points and more or less approximates where those points lie. The line is a model for the data. The data is kind of messy. It's real world. It has some randomness to it, and the line is nice, regular, straight, even. The line approximates the data. The line is a model for the data. So what are we going to do with this relation? First of all, when we get different data sets, there's lots of different ways that that cloud of data points might look. Sometimes the data points are linear, and sometimes they are not. In these first two pictures, these are examples of linear data. And then for the next three, that is not linear data. Linear data is nice because I can draw a line through the cloud of points, and the line kind of approximates where those points lie. For the nonlinear data, I can't really draw a line that really reflects what the data is doing. Okay. So let's model a linear relationship. How do I actually find that line? So let's take the data from the baseball teams that we were looking at before. To find a model for a linear relationship, select 2 points and find the line connecting those 2 points. Okay, let's do that. So, for example, let's take the point 31.5, 690 and the point 33.1, 778. There I've indicated them on the picture, and we'll draw a line through those 2 points. There is a little bit of creativity in this process of picking the right 2 points. There are lots of points that you could pick that would be very bad, right? So if I had picked that first one and the one just below and to the right of it, that would give me a line that does not at all look like the data. So you can pick 2 points, but pick 2 points so that the line that goes through them more or less looks like it runs through the cloud of data points. Then, once we have those 2 points, I can figure out the slope of the line connecting those 2 points. The slope is just the change in the y values divided by the change in the x values. In this case, it turns out that our slope is 55. Now that I have the slope, and now that I have a point, I can use the point slope formula to figure out the equation of the line. And now, it doesn't really matter which point I use. I just choose either point, but label those coordinates x1, y1. Plugging in the information and doing a little bit of arithmetic, we end up with an equation for the line. And we say that that equation is the model. Okay, so now that we have the model, now that we have the actual equation for the line, what can we do with it? Well, there's two things. First, I can use the model for prediction. Let's suppose that some other team has an on-base percent of 32.4. And so, by the way, the data that's up here right now is for 15 teams. There are, in fact, 30 Major League Baseball teams. So perhaps there's some other team that wasn't on the list, but it turns out that they have an on-base percentage of 32.4%. What do you predict their total runs scored will be? Well, this is where we can use the line. So look at the graph on the x-axis, identify 32.4, take it up to the line. And then from the line, move left until we get to the y-axis, and we can see total runs scored. So if my percentage is 32.4, it looks like my total runs scored is going to be somewhere between 725 and 750. Well, I can find that out exactly by actually using the equation. Let's plug in 32.4 in for x. And when I do that, I get 739.5. So I would say, if there is some team that just happens to have an on-base percentage of 32.4, then a reasonable prediction for the total number of runs that they scored will be 739. Yeah, maybe 739, 740, somewhere around there. Another thing that we can do with the model is to interpret slope. The slope has a really interesting meaning. In this case, the slope is 55, but 55, what does that mean? Well, let's remember that the slope tells us how y changes relative to a change in x. In this case, the y is runs scored and our x is on-base percentage. So it turns out I can say for every increase of 1 for on-base percentage, so look at the graph there, if I increase by 1%, there is a corresponding increase of 55 for total runs scored. So looking at the graph, moving to the right by 1% means I go up by 55 runs. If I increase to the right by 1%, I go up by 55 runs. So that might be good for a team to know as they're planning their strategy, and they figure out, how much do they want to increase their total number of runs, and then that would tell them how much they need to increase their on-base percentage. They can see the relationship between those two ideas. All right, and that is it. We have talked about 4.2, building linear models from data. We've seen that data can be put into a scatter plot, and we draw lines through there, and then we can get the equation of the line and draw some interesting conclusions from that line. And that is a good place to stop.